Hey, greetings everyone. We're now at the last lesson of module lesson 11.1. So it's all about the series. So actually, when we were discussing about the summation notation, we were already discussing series. So it's just a matter of defining what a series is. Okay. So here we will define the series and we will give some examples of them. Okay. So let's start with the definition. So consider the infinite sequence A1, A2, A3. So it continues infinitely. And the sum of the first n terms of a sequence is called a finite series. Okay, so this is our summation notation of our finite series. So we are only up to a certain n term right here, an. Okay, so basically, the difference between a sequence and a series is that a series is a summation of the terms of a sequence. Okay. Now, for the second one here, the sum of all the terms of the infinite sequence is called an infinite series. Okay, so we have finite and infinite series. Okay, so what are some examples of this? Let's say we have example 1. Let's have example 1 here. Okay, so we have, let's first do a finite series. So we have right here, so k is equal to 1 and 5 and k minus 1 over k. Okay, so this is in summation notation, and if we expand this, so this is a finite series. Why? Because we have here a bound, an upper bound, which is 5. Okay, if it's an infinite series, then it should be infinity right there. Okay, so let's just evaluate this. So we will have 1 minus 1 over 1, right? And plus 2 minus 1 over 2, plus 3 minus 1 all over 3, and then 4 minus 1 all over 4, and 5 minus 1 all over 5. That should be 5. Okay, 5 right there. Okay, so this will be, so 0 over 1, that's 0. So 1 half, that's 2 thirds, that's 3 over 4, that's 4 over 5. Okay, you can add that up if you want, but this is basically our series right here, not in summation notation. Here on the left is the summation notation. Okay, so let's have example number 2. Example number 2 would be an infinite series. Okay, so you have let's draw our sigma right here, and say n is equal to 1, and we have infinity right here, positive infinity, 1 over 2 raised to n. Okay, so if we expand this, we will get 1 over 2 raised to 1, which is 2, plus 1 over 2 raised to 3, 2 raised to 2, which is 4, and then 1 over 8, then 1 over 16, right? So if we add that up, if we go to infinity right here, this actually adds up to 1. Okay, this is actually equal to 1. So that's an infinite series right there. So you can actually view this geometrically. Let's say if we have a square, we have a square right here, we have a square, and let's say we divide it by 2. So this is 1 half. This is 1 half of the square, right? And 1 half, and then so we have right here our 1 half, right? And then we have our 1/4. Okay, we have our 1 half and our 1/4. Now we have our 1/8, right? Our 1/8 right here, 1/8, and our 1/16, 16th, and then and so on and so forth until it becomes very minute here, but ultimately it will sum up to 1. So that is the geometrical explanation for that. Okay, so now that we know what a series is, you'll proceed with arithmetic and geometric series in the next few lessons. Thank you for watching, and I'll see you in the next video.